Our first function is a polynomial function, so we'll start by using the power rule. F prime of x equals 7x to the 5, well 7 times 5 is 35, x to the 5 minus 1, which is 4, plus we have derivative of 4x cubed, 4 times 3 is 12, times x to the power 2, minus derivative of x, which is 1. And the derivative of 13 is 0, so we don't have to write it. For the next problem, we're looking for square root of x plus square root of 5. So we can look at the derivatives separately. Square root of x is the same thing as x to the power 1 over 2. So we will use the power rule. So that will be 1 over 2 x to the power 1 over 2 minus 1, which is equal to negative 1. So, negative 1 over 2. So I will write that in a little bit. Derivative of square root of 5. Well, 5 is a constant number. Square root of a constant number is still a constant, and derivative of a constant is 0, so we don't have to write it. And let me go ahead and put negative 1 over 2 for the power here. Okay. For this one, we have both a radical and a denominator, but we can write this function as a power function, as a power of x. Since x is in the denominator, we know that the power is going to be negative, and fourth root of x to the third is the same thing as x to the 3 over 4. So this function is equal to x to the negative 3 over 4. So we are going to use the power rule again to find the derivative. So bring negative 3 over 4 in front, and then subtract 1 from negative 3 over 4. Negative 3 over 4 minus 1 equals negative 7 over 4. So this is x to the power negative 7 over 4. This function is a product of a polynomial and a trigonometric function. So we're going to use the product rule. Polynomial is our first function. Trigonometric function is our second function. So f prime of x equals to the derivative of the first function. Derivative of x cubed is 3x squared plus 4x. 2 minus 1 is 1. We don't have to write the power. Plus derivative of 1 is 0, so we don't have to write it. Times the second function, cosine x, plus derivative of cosine x is negative sine x, times the first function, x cubed plus 4x squared plus 1. This problem is just a formula. Derivative of cotangent x is equal to negative cosecant squared x. All right, next page. We have a rational function here, so we're going to use the quotient rule. So f prime of x equals to a fraction. Denominator of this fraction will be the square of the original one, 3x cubed squared. Numerator will have derivative of the top, 10x minus 1, times the bottom, 4 plus 3x cubed, minus derivative of the bottom. Well, derivative of 4 is 0. Derivative of 3x cubed is 9x squared. We don't have to use parentheses, so I skip it. Times the top function, 5x squared minus x. This is our answer. We don't have to multiply it out, but please make sure that you use parentheses where necessary. Otherwise, you will be giving a different answer, not the correct one. Okay, so this number 7 is again just a formula. Derivative of inverse cosine function. It's kind of similar to the inverse sine, but we'll just have negative 1 in the power. So negative 1 over square root of 1 minus x squared. Number 8 is ln of sine x. So here we're going to use the chain rule, where our inside function is equal to sine x. So f prime of x is derivative of ln of I. So that's 1 over I, and Ri is sine x, times the derivative of sine x, cosine x. You could also immediately write cosine x over sine x for your answer. And if you write cotangent x, that would also be correct. Okay, let's take a look at 9. Here we have cube root of pi times x. So keep in mind that this is the same thing as cube root of pi times cube root of x, which would uh, be cube root of pi times x to the power 1/3. So we can find the derivative now. This cube root of pi is just a coefficient of x. It's a number, it's a constant number multiplied to x. It's a coefficient. So put the coefficient. And then derivative of x to the 1/3 is 1 over 3 times x to the power 1/3 minus 1, which is negative 2/3. That's x to the power negative 2/3. So that's our answer. Number 10 is e to the x times ln x. So this is power rule, exponential and logarithmic. So exponential is first, logarithmic function is second. And we're looking for the derivative of the first function. Derivative of e to the x is e to the x times the second function, ln of x, plus derivative of the second function, that is 1 over x, times the first function, e to the x. So we have completed the first half of the master test.